Hi, this video is about hydrates. First of all, what you should have in front of you is a periodic table and a calculator and a pencil and paper so that you can do some calculations along with me. First of all, what are hydrates? Well, as the name implies, it has something to do with water. What it is it's an ionic solid that has some water molecules loosely associated with it. It's a fixed number of water molecules, and that number of water molecules that is attached to the formula for this crystal is separated with a little dot. So here we have a hydrate, and it's copper 2 sulfate, and then there should be a dot. Actually, it's right here in the center. And then there are 5 water molecules that are loosely associated with the copper 2 sulfate crystal, and so that is our hydrate. Well, how do we name these guys? Well, we name our ionic solid just like we learned back in our naming unit. This is copper, since sulfate has a -2 charge. Here we go, let's try this one more time. Because sulfate has a -2 charge, this copper has a +2 charge, so we have to say copper 2, sulfate, and then we use our prefixes. It's the same prefixes we learned for molecular compounds. The prefix for 5 is penta, and then you say hydrate. So pentahydrate. So this compound is copper 2 sulfate pentahydrate. All right, now let's go ahead and calculate what we're going to call the formula weight for this hydrate. All right, well, how are we going to do that, and what does that 5 have to do with it? Well, we're going to go ahead and calculate the formula weight of copper 2 sulfate the same way we did the formula weight of things in our last video. So we had 1 copper, and it is 63.55 AMUs, and we have 1 sulfur, and it's 32.06. And oxygen, we have 4 of them, and that's times 16. 4 times 16. There we go. All right, and then we'll sum those all together. And I come up with a formula weight of 159.61 AMUs for copper 2 sulfate. Now, let's go ahead and calculate the formula weight for water. And this is probably going to be one that you'll have memorized. So we have hydrogen, we have 2 of them, it's 1.01. And we have 1 oxygen, which is 16. And we come up with a grand total of 18.02 atomic mass units for the formula weight for water. Now, what we're going to do here is we're going to add the formula weight that we calculated for the copper 2 sulfate, and then we're going to add to it 5, see that coefficient of 5 in front of the waters, 5 times the formula weight of water. So we sum all that together and we come up with a grand total of 249.7 AMUs. Okay, that is how you calculate the formula weight for hydrates. All right, Epsom salt is a hydrate, and it's magnesium sulfate heptahydrate. Let's see if we can write the formula. Okay, magnesium sulfate. The prefix hepta is 7, so with a dot here, meaning we have 7 water molecules that are loosely associated with the magnesium sulfate. So that's the formula for magnesium sulfate heptahydrate. Now, why don't you go ahead, stop the video, and calculate the formula weight for magnesium sulfate heptahydrate, and make sure you bring it to class tomorrow. After you're done with your calculation, continue on with the PowerPoint. We can also calculate the percent water in a hydrate. So, let's see how we do that. We've got this hydrate, barium chloride dihydrate. To get the percent water, what we're going to do, it's just like percent composition. We're going to put the grams of water and then divide it by the formula weight of the hydrate. And then we're going to multiply by 100. Okay, so The grams of water in this hydrate, 2 times 18.02 is going to be 36.04 grams of water. So that's 2 times the atomic weight of water. I'm sorry, this should be AMUs. This should be atomic mass units of water. We'll get to grams in the next few videos. Okay, so 36.04 AMUs of water. And then the formula weight of the hydrate, and just to save time, I calculated this ahead of time. It was 244.27. And then when we multiply, and that's atomic mass units, when we multiply this by 100, we come up with the percent water in this hydrate, and it comes out to be 14.75%. So 14.75% of this hydrate was water. All right, now we're going to do a lab with hydrates, and just gentle heating can cause them to lose their water. And so if we've got some hydrate, let's just say, oh, it's this hydrate, A, B, I'm just making one up. And then we've got some amount of water with it. This is called the hydrate because it has the water associated with it. And then some gentle heating, and so I'll put a little triangle over my arrow that indicates heat, will cause this water to come off, and it will just go into the atmosphere. Notice now the water is no longer attached to our AB. Here it was attached, that's what that dot means. But now the water has gone off into the atmosphere or something. Okay, now this AB no longer has water associated with it, and so it's called anhydrous. And a lot of times people call ionic solids salts, so it's called the anhydrous salt. When you heat a hydrate, the mass that it loses is the mass of water that was contained in the hydrate. So let's look at what this looks like. You've got a 125 gram sample of some kind of a hydrate, and you heat it up. Once all that water is driven off, the heat drives off the water, 61.1 grams of the anhydrous salt is left. How many grams of water were lost? Well, we started with 125.0 grams, and we only have 61.1 grams left. The difference between these two is the amount of water that was driven off with the gentle heating. And so that's 63.9 grams. All right, so you're going to be getting some data. You'll get the mass of your hydrate. You're going to heat it. It's going to lose mass, and however much mass it loses is the mass of water that was contained in your hydrate. To get the percent water in the hydrate, well, let's go ahead and take the 63.9 grams, and let's divide it by the total sample, our hydrate's mass, times 100. And this particular hydrate would have had 51.1% water. So that's looking at some experimental data and figuring out the percent water, and we're going to do this in lab tomorrow. All right, I would like you to also do problem 3. So go ahead, turn off the video and try problem 3. And a lot of you guys have asked to see my dog Gracie, so I'll see if I can get her in here to say hello. Gracie! Gracie! Come here, Grace. Come on, Grace. Come on up here so they can see you. Come on. Come on. I don't think they can see you. Say hello. Say hi, Grace. Say hi. I'm not sure if that's a good shot or not. Okay, have a good night.